Good day, Doctor. We are from Group 3, Section 2, and today we want to present about the off-grid generation system for a residential house that belongs to the Pendeka Musta. So this is my team member. For introduce myself, my name is Chakikat, AE23005X, and my teammate is Badru Ameh, AE23036, and Huzaifa Miawa, AE230104, and Muhammad Shafiq, DE240169. So for the abstract part, now the rapid change has become one of the most discussed issues in the world that concerns require universal focus and commitment. In Malaysia, approximately 84% of our generating capacity relies on coal and natural gas in the energy mix, and contribution of this non-renewable source is sorted to persist. The continuous development of conventional thermal power plant will only exacerbate the climate crisis and accelerate the climate change. Now imperative for all to take first step towards solving the problem. The Sustainable Energy Development Authority (SEDA), collaborating with the Ministry of Energy, Green Technology and Water (KETA), has taken the responsibility to transiting our country energy landscape from the conventional one, which is heavy depend upon the fossil fuel, to the one using renewable energy. The renewable energy has become a popular source of the electricity generation among the community in this recent year. So there are some type of the renewable energy source which can be utilized to generate the electricity, such as the solar, hydro, and biomass. So for our country, Malaysia, located in the near of the equator, thus it ensures the consistency of sunlight throughout the year. So therefore, solar photovoltaic system have become the most common use for the installation, operation, and the maintenance. So for the introduction part, as we know, the PV system is convert the solar energy direct into the electrical energy. So solar PV is widely used due to the sustainability, reliability, and the low environment impact. So we got two types of the solar system. First is the on-grid solar system, and another is the off-grid solar system. So for the on-grid solar system, it supplies excess electricity back to the utility, when the off-grid system is operate independently from the utility grid and is suitable for the area with the limited or unreliable grid access. So for this project is focused on the design and the implementation of an off-grid solar PV system. So for the application, we use for the single-story residential house, which is Pendeka Musta house, and the system include battery energy storage to ensure continuous power supply during night time or low solar radiation. So system size and configuration are based on the household electrical load assessment. Safety devices such as MCB and RCCB are used to protect the system and occupant, and the key benefit is to self-sufficient and reliable electricity supply, reduce the dependency on the national grid, lower the carbon emission, and for long-term electricity cost saving. Next is the problem statement. So for the rising electricity costs, which increase the financial burden on the household, with the higher energy consumption due to the widespread use of the appliances and electronic devices. The heavy reliance on the fossil fuel contribute to climate change and environmental degradation. Malaysia still using the largest power generation, which is non-renewable energy source. The SEDA is promote renewable energy, especially solar PV, to reduce the carbon emission for the rural and the remote area face unreliable or limited electricity access. Frequent power interrupt affect the quality of the life and the economic development. So strong need for a reliable, cost-effective, and independent power generation system does not rear onto the national grid. So next is the objective. So before we want to go through our project, so we identified few of the objectives. First is to design and implement an off-grid solar PV system for a resident house to reduce the electricity bill and minimize the dependence on grid electricity. Next is to ensure the solar PV system operate efficiently by designing according to the total electricity load of the resident house. Next is to select the suitable protective device such as circuit breaker that need match to the system requirement and ensure the safety and reliable operation. To ensure the system operate at optimum performance based on the total electricity demand of the resident house. Last is to analyze and select the main component of the off-grid system, including solar panel, charge controller, inverter, and load equipment to ensure efficiency system operation. Before installing the off-grid solar PV system on the roof, accurately estimate the total load demand is essential, as it determines the appropriate solar panel capacity need to meet the home energy consumption. So refer to the plant
It includes 2 bedrooms, 1 kitchen, 1 dining room, 1 living room, pantry, backyard, car park, and 2 bathrooms, each equipped with specific appliances that contribute to the overall power usage. Among these are air conditioner in the bedroom and living room, the ceiling fan in living room, dining room, and car park, along with other household.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Badruamin bin Suhairi. Matrix number is AE230036. So for the manual calculation, the total connected load is 4800 watts plus 390 watts plus 300 plus 200 plus 300 and plus 500. We will get 6490 watts or 6.49 kilowatts. So for the total daily energy consumption, we will use 28,800 plus 2,340, 2,400, 4,800, 1,500 and 500. We will get 40,340 or 40.34. And for maximum demand, we will use 6.49, which is the total connected load, times 0.7. So to calculate the load current, we need to find IL by P over VL times PF. VL and PF are already given in the question. So to calculate IL, it is 4,550 divided by 230 times 0.85, which we will get 23.2 ampere. So for IMCB, since our current is 23.2 ampere, we need to get a value higher than 23 ampere. And the next standard MCB value after 23 ampere is 32 ampere. And for IRCCB, it also needs to be higher than IMCB for safety reasons. So we need to choose an RCB with a value of over 32 ampere. The next one is 40 ampere for the RCCB. So this safely provides carrying normal operating installation. Before we proceed with the solar PV array sizing, we need to calculate the PV first, which is the 40.34 kilowatt over 4.5 times 0.8, which we will get 11.2 kilowatts. So the solar array we are using is a monocrystalline. The rated power is 400 watts and the panel area is 2 meters per panel. So for the panel quantity, we can just use the PV value that we calculated earlier, which is 11,200 over the rated power, which is 400, which we will then get 28 panels. So we can round out 28 panels to 30 panels for real operating conditions. For the roof area requirement, we can times 30 panels, we got 30 panels, and we can times 2 meters square for the panel area. So which will then result in a 60 meters square roof area. So this is very suitable for a single story house. For battery bank sizing, we are using a lithium iron phosphate battery, which is the specifications are as follows: 48 volts and stranded AH, and the energy is 4.8 until 5.0 kWh per unit, and the efficiency is 80%. So for the daily energy requirement that we calculated earlier, it is 4.34 kilowatt per hour for a day. So the energy requirement, we can simply do the daily energy requirement divided by the efficiency, which will then we will get 50.4 kilowatt per hour, and the number of batteries is 50.4 kilowatt divided by the energy used per unit, which is 5 kilowatt, resulting in 10 batteries. The inverter sizing, we are using a 12,000 watt 48 volt pure sine wave inverter charger. It works with 48 volt battery bank, and pure sine wave ensures safe operation of appliances. The DC input is 48 volt, the AC output is one phase 230 volt, and the efficiency is 94%. This is for the solar charging controller sizing, MCCP. So MPPT controller with a 60 ampere output is ideal for a 48 volt system with 12 kWp panels. This MCCP also support multiple battery types, including lithium iron phosphate battery that we are using. So first we need to calculate the battery side from the DC charging current, which is the current flowing from our MPP controller to the 48 volt battery bank. The formula is simply I equals to P over V. So the P is 12 kWp and the V is 48 volt, which will get 250 amperes. So we will need two MPPT controller, which each rated 150 ampere. This allows safe current sharing and redundancy. For an economic point of view, the total system cost is 101,000 ringgit from the table above. So we can calculate the yearly electrical cost of site by assuming the monthly usage is 1,200 kilowatt and the tariff is 50 cents per kilowatt, which will then cost 7,200 ringgit annually. And to calculate the expected payback period, we can calculate the total system cost over the money we save, which is 7,200. So we will get 14 years.
Okay, so now I'm going to talk about the off-grid solar PV system prototype and single line diagram. So this slide shows the system prototype and single line diagram of the off-grid solar PV system. Solar panels generate DC power, which is regulated by MPPT charge controllers and stored in 50.4 kilowatt hour life PO4 battery bank. The inverter converts DC to 230 volt AC power for household use. Safety is ensured through DC circuit breakers, 32 ampere MCB and 40 ampere RCCB, providing reliable and safe standalone operation. So now let's look to a comparison of off-grid solar system versus conventional power generation. So as we can see the comparison in the infographic. Compared to conventional fossil fuel power generation, the off-grid solar system produces no emissions and significantly reduces carbon footprint. It provides full energy independence using battery storage, ensuring reliable power even during outages. Although the initial cost is higher, the system achieves payback within 8 to 10 years and delivers long-term economic and environmental benefits.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq Aiman Mizali. My TIN number is DE240169. Today I want to present about the conclusion. So this project successfully designed and proposed an off-grid solar photovoltaic system for a residential house based on the calculated electrical load demand. The load analysis enabled the appropriate selection of the protection device, ensuring safe and reliable system operation. The designed PV system is capable of supplying sufficient electrical energy to meet residential demand with an assumed power factor of 0.85 lagging. Furthermore, the off-grid solar system offers long-term economic benefit by reducing reliance on conventional grid electricity, while also providing an environmentally friendly solution with lower carbon. Thank you. So next, this is our reference. We take this from the website. So this is first one is a Panasonic Corporation. Next is the Philips Lighting, Samsung Electronic, LG Electronic, and software for we do the drawing. This is called Smart Draw. Okay.